Okay, today I'm going to do a quick lesson over basic polygons. So this is going to go really fast. If you need to replay it, that way you get it. So a polygon is a closed, straight-sided figure. For an example, this would be a polygon. You name the polygon according to circling the figure and going by the letters. So we could say that this is polygon A, B, C, D, E. You just name all the vertices of the letter. The name of polygons is written as follows. If it has 3 sides, it's a triangle. If it has 4 sides, it's a quadrilateral. If it has 5 sides, it's a pentagon. If it has 6 sides, it's a hexagon. If it has 7 sides, it's a heptagon, H-E-P-T. If it's 8 sides, it's an octagon. 9 sides is a nonagon. 10 sides is a decagon. 11 side doesn't have a name, so they call it an 11gon. 12 sides is a dodecagon. And anything after 12 is called whatever the number of sides is, gon. So 15 gon would have 15 sides. Now, a convex polygon is one that looks like this. It has no cave in to it. A concave polygon is one that looks like this. At some point, it caves back into it and forms what I call a cave effect. The other name for concave is non-convex. Sometimes the book goes by non-convex. A regular polygon is where all sides and angles are congruent. I consider the regular polygon to be the perfect one. The perfect polygon, because everything's perfect. An example on your template would be this. That's a regular triangle, because it's an equilateral. That's a regular quadrilateral, because it's got 4 equal sides and 4 angles. That's a regular pentagon. That's a regular hexagon. That's a regular octagon. So you can see that they look perfect. Non-regular means not perfect. An equilateral polygon is where only the sides are congruent. An equiangular polygon is where only the angles are congruent. Now, that's basically naming everything and identifying the terminology. Now, the sum of the interior angles of a triangle, as you know, is A plus B plus C equals 180 degrees. That's true for all triangles. The sum of the interior angles of a quadrilateral, since it's got 4 sides, is A plus B plus C plus D equals 360. So what I'd like you to do now is take your template and measure each of these 4 angles, and since it's a quadrilateral and has 4 sides, then make sure that they equal 360. Write the measurements in and make sure they equal 360. I'm going to go ahead and do that right now on my paper, and you should come up with something within a degree of mine, hopefully. So pause it and then start it up again. I got about 103. About 63. $117. And about 76. All right, if I did that right, then they should add up to be 360. I got 359. So that tells me that I'm probably right. I just got maybe a half off here and a half off there. So do the second one on your own, and you should end up with the following measures. This is obviously acute. About 53. T, about 24. R is another acute angle. Probably 28. Now this is interesting because this angle is huge. That's not even obtuse, it's more than obtuse. You know that a full revolution of a circle is 360. So I'm gonna have to subtract out this outside angle to get the inside angle. So I'm measuring the outside angle, and the outside angle I have is about 104. So if this is 104, then the inside angle should be 360 minus 104, about 256. Now if I add them all up, 256 plus 28 plus 24 plus 53 is 361. So again, I'm right there within 1 or 2 degrees, which means that's perfect. Here, solve for X and Y. Again, pause your video and then restart it up. 180 minus 110 is 70. I know that all of these angles add up to 360, so I add these three and subtract from 360 to get 103. Next one, add them all up to equal 360. Do it on your own. That'd be 8x equals 360, so x equals 45. Okay, go ahead and flip the page. If you need to replay this, replay this. Now, on the back, these are the formulas that you really need to pay attention to. They're very important as we go. Okay, first, the sum of the inch angles of a regular polygon, or any polygon, is the following. N minus 2 times 180 equals the total sum. So you just plug the numbers into that and you figure out what the total sum of all of them are. So for example, if it's a 10-sided polygon, which is called a decagon, then we would say, okay, a decagon has 10 sides, so 10 minus 2 is 8. 8 times 180 means that a decagon, any decagon, has 1,440 degrees on the inside. That's the total sum. Now the measure of one inch angle of a regular polygon is this formula. N minus 2 times 180, but this time you divide it by the number of sides or number of interior angles, and you get one interior angle. So for example, if I have a pentagon, that's a regular pentagon. The regular pentagon has the following. 5 minus 2 times 180. divided by 5. 5 minus 2 is 3. 3 times 180 is 540. That's the total sum of all of the angles. Divided by 5 gives you 108. So each of these interior angles is 108 degrees. The total sum I like to write into the middle. Total sum is 540. Each one of them is 108 degrees. Now the sum of the extra angles of a polygon is 360. You can find that out. Well, let's keep going. The sum of the extra angles of a polygon is 360. That's always true, no matter what size it is. So if we ever ask you what's the sum of all the extra angles, you say 360. To determine what the measure of one extra angle of a regular polygon is, you simply go 360, which is all of them combined, divided by n. So in this one, if it's got 5 sides, then 360 divided by 5 is 72 degrees, which makes sense because you know the extra angle is if you extend the side, you create an extra angle. 180 minus 108 is 72 degrees. So that's how you find that out. And if there's 5 of them, then they add up to 360. Now let's work a couple of these problems, and then you can do the rest of this for homework. Work the following problems by drawing a small sketch and showing your work. Find the total interior measure of an octagon. An octagon has 8 sides. So I do this. I make a sketch of the corner of an octagon, and I put the interior angle here, the exterior angle here, and the total sum is going to be over here. I want to find the total interior measure of the octagon. The total sum of the interior angles is this formula. So I go 8 minus 2 times 180. That would be 6 times 180. And 6 times 180 is 1080. So the total sum is 1080. To find the measure of one interior angle, I would go 1080 divided by 8. Each interior angle is 135 degrees, which means the extra angle would be 180 minus 135, 45 degrees. That's one way to get it. The other way is 360 divided by 8 means each of the extra angles is 45 degrees. So you can go through what I call the front door or go through the back door, which would be the extra angle, because you know that. So this is to find the total interior measure. Now here it says find the measure of one angle of a regular decagon. Well, a decagon means 10, and I'm looking for one angle. So if I draw a little baby sketch, I know that one interior angle is this right here. One interior angle is this formula. So I'm going to go 10 minus 2 times 180 divided by 10. 8 times 180 is 1440 divided by 10 is 144 degrees. So one interior angle is 144 degrees. So what's the exterior angle? 180 minus 144 is 36 degrees. What's the total sum? The total sum was 8 times 180, which is 1,440 degrees. So I've got my numbers. Those are the 3 numbers that you need to be able to create when doing these problems. Okay? But answer the actual question. So I'm going to let you try to work through this on your own. You have enough information to complete this, which is your homework. Then answer all these questions over here. Work these out, make a sketch on these like we just did there, and then work these problems on the back. You should have enough information to complete all this. If you don't, then go to the book, Big Ideas Math, to 7.1 and look at more information if you need to. After completing this packet, then This will be assignment number 23. Then go to assignment number 24 in Big Ideas. There's going to be a substitute on Monday, so good luck, and we'll see you on Wednesday.